Imagine someone throwing an orange off an oil platform into the ocean at night. How many seconds do you think the fruit would stay in your line of sight? We didn't use this analogy for nothing. In 1977, the Voyager 1 spacecraft was launched from Kennedy Space Center. That very same iron orange that we sent into the cosmic ocean 48 years ago. And now we're gradually losing it in the infinity of space. National Aeronautics and Space Administration did the impossible. Voyager 1 is still transmitting data, being one light day away from Earth. This means that right now the signal from the spacecraft takes a whole 24 hours to reach us. What has the probe managed to accomplish during its mission? And what incredible efforts is National Aeronautics and Space Administration making to maintain contact with it? Let's start with the latter. At the moment, Voyager 1 is about 170 astronomical units away from Earth, which is, just for a second, 25.5 billion kilometers. No other probe has traveled this far, and today it is the most distant man-made object launched from our planet. Can we really still hear it? Paradoxically, yes. The main component that allows scientists to receive signals is a transmitter operating in the X-band, with about the same power as a refrigerator light bulb. The secret lies in the narrow directionality of the signal. It comes straight to us without getting distracted along the way. This is made possible by a parabolic antenna with a diameter of 3.7 meters, which ensures the signal is accurately directed toward Earth. The last adjustment of the instrument was made in 2017, and now, as they say, Voyager 1 is operating on autopilot. But why have the spacecraft's antennas not deviated from Earth for almost 10 years and maintained an accuracy of 0.1 degrees? After all, no one is adjusting them now, right? Could it be that aliens are secretly repairing the probe in flight to help us explore space? Seriously though, several factors contribute to the high accuracy of signal transmission to Earth. Voyager 1 is equipped with a star sensor, which is the main reference point. The device automatically monitors the brightest image, the star, and thus does not deviate from its course. There is also a solar sensor, which is oriented toward our star. This is a rather crude auxiliary tool that helps to make sure the spacecraft hasn't flipped over. Inside the probe, there are electronic accelerometers, although they are not highly accurate, as well as a preset deadband. This technology assumes that the computer will automatically shut off the engine if the antenna's deviation angle from the ground exceeds 0.6 degrees. What about decoding the signal? Among other things, the spacecraft is equipped with an advanced encryption system, which is surprising for the 1970s. It allows up to 40% of signal errors to be corrected, even when the signal is heavily distorted. And the frequency compensation for the Doppler effect constantly adjusts the receiver to the natural shift during transmission. I see, but what else? Receiving signals from Voyager 1 is handled by 3 huge antennas located in the United States and Spain. Each antenna has a diameter of 70 meters, and they are capable of detecting a signal with a power of 10 to the minus 18th power. That's the same as seeing the flicker of a candle from about 20,000 kilometers away. On board Voyager 1, in addition to its sophisticated equipment, there's a golden message record, which has been talked about by almost everyone over the past 48 years. So we won't repeat it. We'll just express hope that over billions of years, someone besides us will get to know this record. But is it really just about the technical equipment of Voyager 1? Was the success of the mission only dependent on this factor? Of course not. The environment in which the probe is immersed also plays a role. External forces in interstellar space are completely absent. There is no solar wind, no atmosphere, no gravity, meaning that almost nothing from the outside affects the spacecraft. If that were not the case, the success of the probe would be in serious doubt. How much longer will Voyager 1 remain relatively stable so that it can send signals to Earth? National Aeronautics and Space Administration specialists believe that without course correction, the spacecraft will show signs of life until about 2032, and then it will go to sleep and embark on an eternal journey through the universe for billions of kilometers, carrying Earth's imprints into the depths. It is possible that scientists will decide to activate Voyager 1's engines. In November 2025, such a test was carried out, and it turned out that the engines work perfectly after 37 years of inactivity. What information did the famous probe manage to transmit during its operation? Were the tremendous efforts of National Aeronautics and Space Administration as engineers and astrophysicists in vain? Let's first mention the data transmission speed. In 1977, it reached up to 115,200 bits per second, but now it's only 160 bits per second. In practice, this means that a single photo takes several hours to transmit, and if there's a whole batch, it takes at least a day. But modern scientists can't afford to be picky. Beggars can't be choosers. What options do they have? The discoveries made by Voyager 1 literally turned Earth science upside down. As you know, the spacecraft flew by Jupiter, which at that time was a completely unexplored gas giant, not to mention its moons. In the 1970s, it was believed that all of Jupiter's moons were cold and dead, but Voyager 1 dispelled this myth because it showed the active surface of Io. It recorded 9 volcanic eruptions at the same time, with Loki spewing sulfur fountains up to 300 kilometers high. Jupiter's moon, Io, became the first geologically active celestial body, and this forced scientists to reconsider previously formed hypotheses and create a new theory of tidal heating. The second unexpected discovery concerning our gas giant was the detection of a thin ring system, which truly shocked astronomers. This formation is not visible from Earth, so if it weren't for Voyager 1, no one would have known that rings are a common phenomenon among gas giants. After all, due to their immense gravity, such planets act like a vacuum cleaner, attracting everything that doesn't fly well. Among other things, the incredible magnetosphere of Jupiter was discovered, stretching 650 million kilometers in diameter. If it weren't a volume, but a solid object, we would see Jupiter's magnetosphere from Earth as an object the size of the Moon. Next, the probe visited the vicinity of Saturn. What scientific myths was it able to dispel? This time, the misconceptions were about the rings. Saturn's rings were previously thought to be smooth and uniform, but Voyager 1 showed the real picture. It turned out there are many rings. There are gaps between them, strange dark structures, up to 20,000 kilometers long, and intertwined threads. The spacecraft also discovered new moons of Saturn, specifically Pandora, Prometheus, and Calypso. The first two, for the first time in the history of astronomy, became confirmed shepherd moons, keeping Saturn's F-ring from breaking apart. Through the eyes of Voyager 1, people on Earth also saw Titan, and as a result it was discovered that it has a dense atmosphere. This immediately placed the celestial body among the candidates for the search for biosignatures. Based on this data, a mission to Titan called Dragonfly is being planned for 2028. Were there any touching moments during Voyager 1's journey? Yes, and that's the famous family portrait of the solar system when the spacecraft, being 6 billion kilometers away from Earth, took pictures of all the planets in the solar system except Pluto and Mercury. In this photograph, Earth appears as a small pale blue dot, just 1 pixel in size. The historic photo was taken on February 14, 1990. This information is well known to anyone interested in astronomy. But how did it actually happen? The group photograph was made from 60 individual frames, later assembled into a mosaic. Who was the initiator of this action? Carl Sagan, in fact, spent a very long time, literally years, convincing National Aeronautics and Space Administration specialists to take this picture for history. The agency's engineers were categorically against it, because to get these shots they had to blind the solar sensors. As a result of turning the probe, the spacecraft would also have to lose contact with Earth for several hours. Why was Carl Sagan so insistent on this picture? The thing is, in February 1990, Voyager 1 was irreversibly heading into interstellar space, and this was the last chance for such a photograph. After a series of pictures in June 1990, the cameras were permanently turned off to save power. I want to thank Carl Sagan for giving humanity the realization that all of Earth's history, the joys and sufferings of each of us, thousands of self-assured religions, prophets, kings and commanders, victors, and the defeated, all of this is gathered on a speck of dust suspended in a sunbeam. Did Voyager 1 pick up any strange sounds? In general, no, because there is no air in space, but the plasma wave science instrument constantly recorded fluctuations of charged particles. Scientists converted this data into audio format for more detailed analysis. And this is what the plasma tsunami sounded like as they engulfed the probe when it entered interstellar space. What is the future of Voyager 1? It faces the fate of an eternal wanderer. The mission has long since gone beyond its originally planned scope, and now the spacecraft is moving away from us at a speed of about 17 kilometers per second in the absolute vacuum with a temperature of minus 270 degrees Celsius. The life of Voyager 1 is divided into two parts: communication with Earth and passive travel. At the moment, the spacecraft is close to the second part of its existence. Its life is supported by 3 radioisotope generators operating on the basis of the decay of plutonium-238. Since this process is not eternal, the RTGs are gradually losing their power, despite National Aeronautics and Space Administration's attempts to save energy by sequentially shutting down non-critical instruments. In February 2025, the cosmic ray detector was deactivated. In 2022, instruments for studying the heliosphere were shut down. By 2030, only the transmitter for telemetry engineering data will remain. And in 2036, at a distance of about 225 astronomical units from Earth, there will be complete silence. Voyager 1, and it will enter the second phase of its existence, embarking on an endless journey along the cosmic highways. What will Voyager 1 encounter on its path? After all, now the samurai has no purpose. In about 300 years, in the year 2325, the spacecraft will reach the inner edge of the Oort cloud, through which the probe will travel for about 30,000 years. Will Voyager 1 collide with comets in this region? Presumably, the small size of the probe and the low density of comets in the Oort cloud will allow it to avoid this scenario. It will take the spacecraft about 40,000 years to reach the star Gliese 445 and safely pass by, and only at a distance of 100 light-years will Voyager 1 finally be completely free from the sun's gravity and continue drifting toward the constellation of Fucus. The spacecraft's titanium body will withstand cosmic dust, gas attacks, and possible minor collisions, so it will most likely outlast even our sun. However, let's not turn off the antennas. If Voyager 1 does speak again after years, or if its signal is heard by our descendants, it will be absolute proof of the existence of an advanced extraterrestrial civilization. In the meantime, we're taking bets in the comments.